Hello and welcome to my YouTube channel. In this channel, I bring forth to you tutorials and short lessons that better your understanding on mathematics and other related fields. This channel will help you prepare for your upcoming national examinations such as the Common GC exams and other concours. So this question for today is allocated for advanced level students, and the question reads: express in partial fractions the following algebraic fraction: x squared minus 6 divided by x minus 1 or x squared plus 1. So without wasting much of your time, let's dive into the solution. So recall, when we have a partial an algebraic fraction like this, to express it in partial fractions, the first thing we need to observe is the power or the degree of the numerator as well as the degree of the denominator. If the degree of the numerator is less than that of the denominator, then you apply the normal techniques as follows. When we have, for instance, here the degree of this numerator here is what? 2, while that of the denominator is what? X times this, that's x to the power 3. So the denominator, the degree is 3. So this one, is a proper fraction, so we can partial fract it as follows. Now for every linear factor, it will decompose to a constant at the numerator. So x minus 1 is a linear factor because it's raised to the power 1. So doing that, we are going to have a to the a divided by x minus 1, and the other one is a quadratic factor, and for every quadratic factor it will decompose to what? A linear factor at the numerator, so bx plus c divided by x squared plus 1, because this other factor here is a quadratic factor. Now a, b and c, they are all constants, which we are going to find as follows. Now we are going to use a coverup method to look for a, b and c. Yes, once you can get a value for x that can change this denominator to 0, then you can get this guy at the numerator. So the first thing here, to do this, we are going to use a coverup method to solve for a, b and c. Now to do that, we take it let's start by solving for a. We take a denominator of where a is found and equate to 0. Solving that gives us x equals to 1. Now in that case, using the coverup method, this is what we are going to do. Since we have equated this factor to 0, we are going to cover up this term on the left hand side. When we cover up this term, we'll be left with what? X squared minus 6 divided by x squared plus 1. That is exactly what we are going to write for a. So a is equals to what? X squared minus 6 divided by x squared plus 1. Now x is equals to 1. You replace x by 1 and you get the value of a directly. Doing that, we have minus 5 on 2. So let's go forward now to look for the constant b and c. So similarly, we are going to equate the denominator where vx plus c is found. So we equate the denominator to 0, and solving that gives us x equals to the square root of minus 1, and the square root of minus 1 is the imaginary number denoted by I. It's a complex number. So I will take this guy now. I come to this, the fraction that I was asked to resolve in partial fractions, I cover up the term where bx plus c is found, the denominator, I cover it up. So when I cover up this guy here, I'll be left with what? X squared minus 6 divided by x minus 1, right? So now it means that my x is what? I. So I'll have what? Bi plus c. So that's what I have. Bi plus c equals to what? On the left hand side, I have what? X squared minus 6 on x minus 1. So I'm just replacing x by I. That will give me what I have here, I squared minus 6 divided by what? I minus 1. I squared by definition is negative 1. So negative 1 minus 6 gives us negative 7, and I copy the denominator. That will give me the following result. Now we have to rationalize this fraction here so that the imaginary term is found at the numerator, not at the denominator. The other way we can do this is to multiply the numerator and denominator of this fraction by the conjugate of the denominator. To get the conjugate of the denominator, you simply replace I by minus I. That is just how you get the conjugate. So that will give me, when we replace I by minus I here, we are going to have what? Negative I minus 1, right? So I'll multiply negative I minus 1 to this fraction here at the numerator and denominator, which I did. Now simplify this by expanding normally, leaves us with this. That is negative 7 times negative I is 7 i's. Negative 7 times 1 times negative 1 gives us positive 7. As denominator, we have what? I times negative I. That's negative I squared. And we know that I squared is negative 1. So negative 1 times negative 1 gives us 1. I times negative 1 gives us negative I. Negative 1 times negative I will give us positive I. And negative 1 times negative 1 gives us 1. So simplifying that, we get 7i plus 7 divided by 2. So we just separate it into 2. That's 7 over 2 plus what? 7i on 2. So basically this is the result. Bi plus c is equals to this. It means, remember, b is the imaginary part of this complex number, while c is the real part. So this is the real part here. This is the real part. Why this is the imaginary part? The imaginary part is a part that contains the imaginary number I. So this will leave us with the answer b equals to what? 7 on 2. That's the imaginary part. And also c, a real part, is 7 over 2, as you can see here. Now once you have the constant a, b and c, we can now write down the general the answer to this question. So we are going to have our fraction, our algebraic fraction, to be equal to negative 5 on 2 divided by s minus 1. So you can just simplify that by multiplying the numerator and denominator by 2, and the 2 will just drop down the numerator to the denominator. And then we are going to have we know b is 7 on 2, so you have 7 on 2 x plus 7 on 2, that's c. And then now when you simplify by multiplying the numerator and denominator by 2, we end up having 7x plus 7 divided by 2 into x squared plus 1. So that is the answer to this tutorial question. And please, if you have not subscribed to this channel, don't forget to subscribe, share this video, and like the video. I also like you to drop your comments and dislike about this video in the comment section. And see you guys in my next video. And please, if you are new to this channel, don't forget to subscribe and turn on the notification bell if you have not yet done that, so that whenever new content is uploaded, you'll be the first to be notified and you not miss anything. So thanks you guys for watching. and see you guys in my next video. Bye bye.